problem in that little pinkish spot says, a clothing store uses stacking crates for storing jeans. The manager orders 42 crates. 6 crates will fit in one row along the wall. How many rows of crates will there be? I want you to reread that problem in your head. This part right here, kind of like a peachy yellow color. Somebody tell me what's just happening in this problem. I don't care about the numbers. I don't care about the math. I just want to know what's going on. Brinley.
The clothing store is using crates to store jeans.
Yeah, perfect. The clothing store is using these crates to store some jeans. How many crates do they have? Not a trick question. How many crates do they have? Bailey?
They have 42 crates.
They have 42 crates. Can you imagine like going to the store and there being just stacks of crates? That would be like so many. So many. 6 crates will fit in one row along the wall. So one crate will go here, one crate here, one crate here, one crate here, one crate here. But that's only 6. So where are they going to put the other 42 of them? 6 will go on the wall. What are they going to do with the rest of them?
Keep on doing that.
Brayden?
Stack them higher.
Stack them. Just like a bookshelf, right? You might have one layer, and then you can stack another crate on top, and another crate on top, and another crate on top. Azalea, what you thinking?
I just realized.
Yes.
These numbers?
Yep.
How come the numbers one?
Crazy how that happens. Crazy town. So this array is actually our model of what's happening. They've stacked their 6 against the wall, and then exactly what Brayden just said, they just kept stacking up.
And it's showing us the number of how many plates they had at that time.
Ooh, I love that. Easton said these numbers on the side, put your finger on those numbers. Those numbers are showing us how many crates they had used at that time. No, you're not going to sit there and squish it all day. So that first row, it only has a 6 because they've only put up 6. The next row has a 12 because they've only stacked 12 so far.
It's counting by distance time.
Yep. All right, so let's look at our model it section. It says use a multiplication or division equation to find the number of rows. We know that each row has 6 in it. How many rows are there? I love that I'm seeing fingers move because you're counting. Lucy? 7. 1, 2, 3, 4, 5, 6, 7. 6 rows and 7 columns to make an array gives us our multiplication equation. Go ahead and fill in that 7. Yes?
6. 7.
Yeah. Equals 42. Love that. What about division? What's that division problem going to be? Scarlett?
42 divided by 6.
Can we say it with our division language? Remember what I told you that division symbol means? Ooh, someone remind Scarlett, what does that division symbol mean? Grace? Nope, that's multiplication. Multiplication is talking about making groups. What is division doing? Bryce?
42 put into 6.
Put into 6 what? Scarlett, back to you. 6 groups. Draw an arrow from this division up to this empty space. And we're going to write 42 put into 6 groups. That's what division is doing. We are putting into groups Just like our dealing out, just like we did with our counters last week, we're putting things into groups. That's what division does. Well, now let's finish our equation. 42 divided by 6 equals, what's going to go there? Ethan?
7.
7.
Because for the multiplication with 7, and if you just switch the quotes at the end,
Yep.
because it is a division question,
Yep.
because the whole has to go at the beginning, you now have to put quotes at the end, and if you already have the 6 from the multiplication section, you have to add the 7 from the multiplication section.
Yeah, you're totally right. Let's look at the bottom. I see 2 really long equations. What is happening in those equations? Let's start with this top one. Right there. It says start at 0 and add 6 till you get to 42. What are they doing? Why are we doing that? What is happening there? Miranda, what are they doing?
They're adding 6s.
Yeah, why?
So they can get 42.
Yeah. What equation or what math can I use to solve that other than addition? Obviously, I can see it's addition. Emma? Yeah, that is our repeated addition, aka multiplication. Let's go ahead and write that. Repeated addition. And then I'm going to write aka multiplication. I can't write very small. Squish it in there as best you can. I know. It's really hard to read the multiplication because my marker is really fast. Multiplication. It's written in the model it section if you're confused how to spell it. So that's cool. We've seen repeated addition before. We've even used repeated addition before. That's usually Bailey's go-to method, and I love it. But what is happening in that second one? Holy moly, what is going on in that second equation? That looks crazy town. Can I handle all that? Azalea, what's going on in that second equation?
I have no idea.
Well, why don't you look at it? That would be a great starting point.
It's like subtracting 42 minus 6 minus 6 minus 6 minus 6. I'm trying not good.
All right, go for it, Azalea. Try it again.
Minus 6, 6 minus 6 minus 6 minus 6 minus 6 minus 6 minus 6. Let's do minus 7 sixes for now.
Minus 7 sixes.
Because that was just these counts.
Yeah. So it's subtraction repeated over and over again. If we think back to when we did our number line yesterday, what did we say happens when we do repeated subtraction like that? Do you remember, Dominic? I'm doing division. It's like skip counting backwards. Super hard to do if you're just skip counting, but you could subtract each time. So we're going to write repeated subtraction, aka division. You got it. What do the numbers in the problem stand for? AKA, what do they mean? Let's start with the easy. Let's start with 42. Go ahead and write 42. It should be a tab. In our problem, what was 42? 42 bananas? $42.
42 was a whole.
42 was our whole, so I'm going to write a W above it because it was our whole, and it was 42 what, Brayden?
Boxes and things.
No, it wasn't boxes. Go back and look. Crates. 42 was the number of crates. Number of crates. That's what 42 was. Number of crates. Easy peasy. Gavin, you don't have your book. You should definitely not be messing with somebody else. Our other number that we were dealing with was 6. What does the 6 mean? 6. Look at our problem. What does the 6 mean? Really?
I think they were the number of rows.
Oh, yeah. 6 were our number. It's not technically rows, because remember we went up. So we could call them groups or we could call them columns. Yep. Now, Brinley, is 6 a part or a whole? A part. I'm just going to add a little P beside it to remind me that's my part. And then I had, we figured out, a 7. What does that 7 mean? What does the 7 mean in this problem? Eliana, what does the 7 mean?
The 7 was how many places that were going up.
Yes, I love that. The number of crates stacked. The number of crates stacked. Gavin, if I am writing, you are writing. Eliana, I'm going to ask, is that a part or a whole? It's a part. It's a part. Let's look at number 12. It says use the symbol, question mark, to stand for the unknown number. Write a division equation that can be used to solve the problem. What could I have written? Azalea?
42 divided by 6 equals 7.
There's no question mark in that equation. There we go. 42 divided by 6 equals, oops, I wrote division again, equals question marks. Because we're trying to solve how many stacks there were, or how many in each stack. We, yes, already did that, but that's what it wants you to do. Normally, I put box so that I can fill in my box. They just chose question mark. It's all the same. What would be a multiplication equation? Dominic? Love, 6 times question mark equals 42. You can use your part whole to get you there. How many 6s are subtracted from 42 to get to 0? You could have counted on that next page. How many 6s are subtracted from 42? Gavin, you should be writing. Look on that other page. Miranda? 7. 7 6s. What's my solution? AKA, what's my answer? What's my answer? Ethan? 7. 7 is my answer. question mark is?
Question mark equals 7.
Question mark equals 7.
Because that's what I did on last time.
Alright, I want you to find a partner at your table. And I want you to solve number 15 together. As soon as you have number 15 solved, bring it to me to check, and then math choice board.